Okay, everybody, let's look at the last section from Chapter 5. It's the Trapezoid Rule. This is just another way to approximate areas under curves. Now, hopefully you do remember about our rectangular approximation methods, right? Those were two. That was another way, the midpoint, the RRAM or the LRAM. And trapezoids are another way to approximate the area. So we're going to look at this approximating the area of this graph. So take a second and pause me and sketch that graph on the interval 0, 2. And then we'll look at this whole divide into intervals of equal width. So take a second and graph that graph and make sure you got it. Okay, so at 0 we have a value of 5. And at 2 we have a value of 1. And I know this is a parabola that opens down. So hopefully we didn't do too much craziness trying to graph that. Alrighty, and now this says we're going to divide this into 4 intervals of equal width. So first of all, decide how wide each interval will be. Each interval be 1/2. There is a formula for that also. You can take your b minus a, 2 minus 0, and divide it into the partitions that you need, the number you want to use, and you can get that each one will be a width of 1/2. This is a formula that always tells us our width of our interval. Okay, and now what I'm going to do is make these into these partitions just like we did in the RAM, make them into vertical partitions, and our decision in the RAM was to decide where we put the top on a rectangle. Did we go from the left or did we go from the right? We don't have to decide any of that. There's no such thing as a left or a right trapezoid. It's all just making a trapezoid. So, and the problem is our trapezoids don't look like this, which is unfortunately what most of you think all trapezoids look like. A trapezoid has 2 parallel sides, and that's it. So our trapezoids are going to look like this. They're going to have these 2 sides parallel. The bottom will be the width is flat, and the top is where we're going to connect diagonally. So there's really no such thing as a left or a right. So let's make some here. Oops, here we go. And there we go. It looks like my trapezoids are going to be a bit under my actual curve, right? Okay, and so let's look at this. And now all we have to do is find the area of 4 trapezoids. Herein is probably maybe where another problem presents itself. So make sure you have noted that the formula for an area of a trapezoid is 1/2 times the sum of the bases. Remember, the bases are the parallel sides times the height. And the height is this. The height for us is, this will be our base 1, base 2, and this will represent the height of the trapezoid. Okay? So let's go ahead and find the area of all of those. You can pause me and do that, and then you can come back and make sure you got it just fine. So I'm going to take 1/2, that's part of the formula, times the sum of the bases of the first one. That would be 5 plus, and then if I plug in 1/2, I get 1/4. 5 minus 1/4 is 4.75. So 1/2 times the sum of the bases times the height, which is 1/2. And I'm just going to go ahead and do this for every single one of those. I'm going to take 1/2. It's kind of redundant, I guess, take the halves there, but I'm going to do it this way anyway. And this one will be the sum of the bases, which this one we've already got, 4.75. And then we're going to add it to the base. When you plug in a 1, you get a 4. So 1/2 sum of the base times the height, that was this one. And now we're going to do this one. We've got 1/2 times the sum of the bases. Okay, this one we already got was 4. If you plug in 1.5 there, I'm getting a 2.75 times the height. And then the last one, which is this one right here, is going to be 1/2 times the sum of the bases. I got 2.75 plus what's this side would be what I get when I plug in a 2. I'm getting a 1 times the height again, okay? And then you can get in your calculator and you can figure out what all this is. And we're approximating the area, and it comes out to be about 7.25. And then I'm asking you if you think this is an over and under approximation. Go ahead and you can think about that and make a decision here. Okay, this is an under approximation because you can see that those, let me finish writing out approximation. Why I chose to do that, I don't know. But this is an under approximation. You can see that our trapezoids lie below the curve. So it does make some sense. And now let's prove that we are pretty close here by using actual fundamental theorem of calculus to find the area under this curve on the interval 0, 2. That's what we were approximating. This is what it looks like in calculus. And let's go ahead and see what we got. The antiderivative of this, I'd have to go up a power, multiply by the reciprocal. Take the derivative of this, make sure it gives you negative x squared. And then we'll do the 5x. And then we're going to integrate. We're going to plug in a 2, so I'm getting negative 8/3 plus 10 minus, plug in a 0. That's easy. And that's going to give us negative 8/3, common denominator, so we'll do 30/3, should give us 10. And that gives us 22/3, which is 7 1/3. So our answer was, under, like we thought, but not too far so. Okay, let's just do one more of these. I'd like you to pause me and kind of go through that process of deciding how wide each of these widths would be and getting some values here. So let's go ahead and do a sketch of the sin x and go through the process of dividing using 4 intervals of equal width, graph it, draw the trapezoids, find the area of the trapezoids, and you may use your calculator to find that area. You don't have to, do it all by hand, but come up with a decimal approximation to 3 places for your area. Worst sine curve ever. Alrighty, let's try that again. There we go. Not much better, but we'll call it a day. All right, I need 4 intervals, so I'm going to have to go with a pi over 2, pi over 4, 3/4 pi, and a whole pi. I'm going to kind of divide them that way. This is really terrible. And we're going to make some trapezoids. So I'm going to go from 0 to pi. Yeah, 0 to pi. I'll go here. I'll go here. I'll go here. And I'll go here. You're definitely going to have to imagine some symmetry there. And then we'll find out, what we got here. So I got a little tired of writing the height and the width for each of these. So I'm just going to kind of factor those out. We know the width of each of these is pi over 4. And I know that the half is part of the formula, right? 1/2 the width times the height. And now I'm going to do is just put a bunch of sums of the bases. So there's a sum of the base, 2 bases. Here's a sum of 2 bases. I'll add it to this. So we can just do some distribution here. All right, so I'll have to write smaller as I get to the end. Alrighty, so when we plug those in, I'm getting this base is 0. It's really a triangle. And the height, the sine at pi over 4 is root 2 over 2. And you can go ahead and do that if you want. Sorry, my dog was barking. I had to pause it here. I don't know if you could tell that or not, but that happens. Okay, and then we're going to go ahead and from that was this trapezoid area, or triangle if you want to call it that. The asterisk, okay, I gotta do 1/2 times the base, and then times the height, and then I'm going to sum up the two bases, which are sine of 2. We already had this one, and the sine of pi over 2 is 1. And then for this one, we're going to sum, once again, the 1/2 and the height, and then we're going to get this base, which is 1, and this, which is root 2 over 2. And then we're going to go ahead and we're going to need this base again, which is root 2 over 2. And then this base is 0, or you could use the triangle formula, but I'm using the trapezoid rule, so there you go. And if you go through all this, you can get a decimal approximation. Comes out roughly to that, to 3 decimals. And would you guess this to be an over or an under approximation? Okay, once again, this is going to be an under approximation. And you can tell that our trapezoids lie below the curve, and we'll make some judgments about that in class also, but you can always draw it to decide. And then let's see, with the fundamental theorem, let's go ahead and actually integrate this. You should be pretty good at this one by now. I think we've done it quite a bit, but if you integrate sine, get negative cosine, and then we plug in the upper bound, minus negative cosine 0, and so this will be a plus, of course. So cosine at pi is -1, so we get negative 1. And then we're going to add the cosine, that's a 0, not a theta, sorry, cosine 0, which is 1. So we're basically getting 1 plus 1. Okay, so we definitely were a little bit under. All right, folks, that's it for the trapezoid rule, just another way to approximate areas under curves.